My name is Guillaume. I'm working for Andromede Oceanology, a French company working about everything which is related to the marine sciences, sea bottom mapping, ecological surveys. And we mostly work in the Mediterranean, but sometimes we do a few missions overseas. We've been working with Sulubai Foundation for a few years now, and we got involved in the Sea Academy project to help collect particular data that will help the management of the bay, of Sharkfin Bay. In order to help the management of the marine protected areas, we focused on three main things, which is the mapping of the seafloor, so marine cartography, photogrammetry, so which are 3D reconstructions of coral reefs that we do by taking pictures, and monitoring of seagrasses. So we first worked on the seagrass habitat because it's a nursery for many different fish species, so it's a very important habitat. And we deployed transects, so lines along which we monitored specific indicators within quadrats, so very small squared areas where we counted the seagrass density, so the number of shoots we have per square meter, which is a good indicator of the habitat ecological value. And then also counted and inventoried the different species that we observed. Also animal species, we've seen a couple of seahorses on one of the transects. Also eventually the sponges that we observe, and also measuring the leaves and quantifying the epiphytes that are very tiny algae growing on the leaves, and that give a rough idea of the quality of the water. Obviously, we also worked on the coral reefs, so we decided one reef, one area on each reef of each marine protected area, where we used photogrammetry as a technique to survey this. So photogrammetry is a technique that allows building in 3 dimensions an object or a scene through the merging of lots of different pictures that we take underwater. And this helps build the 3D model from which then we can compute different indicators, list all the species that we observe, measure the 3D complexity of it. The nice thing with photogrammetry is that it's very accurate, so it gives the very precise shape of the reef, and this helps to come back in time later on and really overlay the 2 different models. And this allows to follow in time the growth of the corals, the evolution of the species, and the percentage of hard coral, living hard coral over the dead coral. For the management of the area, it's very important to have a good idea of what we have underwater. So sea bottom mapping is the first thing that we have to do to have a precise idea of what we have at what location. So we mapped the seafloor using 2 different devices. One is an eco sounder, so this gives the depth, and we have a 3D map basically of the seafloor. And the second technique is a side scan sonar, which gives an imagery of the sea bottom, just like an ecography of the sea bottom. And the image depends on how soft or hard the substrate is. That part is the reef. We're following Silanga's reef on the right side. On the port side, this is the muddy area, more like within the channel in between the 2 islands. We mapped the 4 MPAs, 4 marine protected areas, with those 2 techniques, the eco sounder and the side scan sonar, which gives a very nice and accurate mapping of everything that we can observe underwater. So all these data then can be used as a baseline for future studies as a reference, and will be made available to the local communities to improve the management of their marine ecosystems.